Hey students, in this video we're going to cover the shape of hyperbolas. The first thing that I want to talk through is the general shape of hyperbolas can be either a vertical hyperbola or a horizontal hyperbola. Hyperbolas are kind of like sideways, or they're a double parabola, but they're a little bit more specific, and then they have what are called slant asymptotes. Let's take a look at the interactive and we'll see how this works. It's important to understand there's two different orientations, and based on the orientation of the graph, we're going to find the features slightly differently based on the orientation. Okay, so the first thing that I want to show you guys is just kind of the basic shape of the hyperbolas. Hyperbolas are kind of two, they look kind of like parabolas, and there's two of them. They can be horizontally oriented like the one I have here, or they can be vertically oriented where the two parabolas are on top of each other. If I showcase the features, so let me take a second, I'm going to highlight all the hidden features that don't show up on the graph. Okay, so here it is with all of the guide features. So the center of the parabola, or the hyperbola, is the point in the center of the shape. If I change my h and my k values, I can change the center of this parabola. Okay, I can also change how wide apart the vertexes are. So the vertex is the 2 points that are kind of like the min and the max values. If I increase my A here, I can make my vertexes closer together or further apart. And this A value is about how the distance from the center to the vertex. Okay, the other thing that I can change is my B value. And my B value paired with my A value dictate the slopes of these slant asymptotes. We call them slant asymptotes because as I zoom out on my graph, the hyperbolas approach these slant asymptotes but never quite reach them. The other thing that A and B can dictate is how close and how narrow your foci are. These hyperbolas have a focus, one in each of the curved shapes. Okay, so now that we've kind of explored all these features, we're going to use our formulas to find these features for a graph and graph them. Okay, my first problem says to describe all features and graph the hyperbola below. We have x minus 4 squared over 16 minus y squared over 25 equals 1. This equation is a lot like our equation of our ellipse. The biggest difference is going to be the fact that we have a minus in between our x component and y components squared. The minus in between is what makes them hyperbolas instead of ellipses. Okay, so the first thing that I'm going to do is I'm going to recognize my orientation. Similar to the parabolas, it's all about which one comes first and which one is positive in this case. So here, when the x component comes first and is positive, it's going to make it a horizontal parabola, or in this case, sorry, hyperbola. This is a horizontal hyperbola. Before I start to identify my features, similar to my ellipses, it's nice to go ahead and have all of my values. So my value with x is my h, so my h value here is 4. My addition value with y is my k value, since there's not one at 0. I can also find my a value because I know that the a squared, in this case a squared is equal to 16, so a has to be plus or minus 4. And then my b value is the fact that b squared is equal to 25, and so b has to be plus or minus 5. Okay, going down my list of features, the first thing that I'm going to find, and again, this is a horizontal hyperbola, so I'm going to be looking down my horizontal list for my features. The first thing after the equation that I can find is the center. The center is at HK, so in this case, 4, 0. I can find my vertices. Because it is a horizontal hyperbola, I'm going to add my A value on and subtract my A value onto my center horizontally. So it's H plus and minus A, K. H is 4, plus and minus my A value 4, comma, K, in this case 0. I'm going to evaluate these. 4 plus 4 is 8, 0, and 4 minus 4 is 0, 0. I'm also going to find my foci. To find my two foci, I'm going to need H plus or minus C. So my 4 plus and minus C, comma, K. And I need to find my C value. Similar to ellipse, hyperbolas have what's called a Pythagorean relationship, which is about the distance between the foci and the center. You can find this by doing C squared is equal to A squared plus B squared. And we have our A and B value. So A squared, 4, is my A value, so A squared is 16, plus my B squared value, 25, and that's equal to C squared. Pause the video and see if you can solve for C here on your own, and then find your foci. Okay, pause the video and check your work. I found my C value to be plus or minus 6.4, and so when I added that onto my center and subtracted that from my center, I got 10.40 and negative 2.40. Okay, the last thing that I can find are going to be my asymptotes. My asymptotes are two lines. And the first one is y minus k, so in this case y minus 0 is equal to plus and minus my b over a value. Now I don't need the plus and minus here because the plus and minus is already taken care of. These are two separate equations, so the first one is the one with the plus, and so this would be 5/4 times x minus h, so x minus 4. Okay, now that I have all of my features, I'm going to sketch a graph of my hyperbola. First thing I'm going to do is set up my axes, and I'm going to start to plot my points of interest. First thing I'll plot is my center. Next, I'll plot my vertices. Next, I'll plot my foci. And the last thing that I need in order to be able to truly sketch my graph are my asymptotes. The easiest way to graph your asymptotes is to start at your center and follow your slopes from the center. So my slope of my first asymptote is 5/4 and then negative 5/4. So I'm going to start at my center and I'm going to go rise over run to get the next point on my line. So I'm going to go 5 units and I'm going to run 4 units going over 4. This gets me another point on my slant asymptote, and the slant asymptote is going to be a slanted line through these 2 points. To get my other slant asymptote, I'm going to do the same slope but the negative form. So I'm going to go down 5 units and to the right 4 units. And this gets me another point on that other slanted slant asymptote. So there's that other slant asymptote. Okay, once you have your asymptotes, your hyperbola is going to start at your vertices, wrapping around the focus. We're going to approach the slant asymptotes but never touch them. So again, wrapping around the focus and approaching but never touching our slant asymptotes. Okay, that's it for graphing a hyperbola. I'll give you an example for you to try on your own. Okay, here's one to try on your own. We're going to describe all the features and then graph the hyperbola below. So the first thing I want you to figure out is decide what type of orientation it should have and identify your H, K, A, and B. Pause the video and try that now. Okay, check your work. I got that this is a vertical hyperbola. My H is 2, my K is 1, and I got A as plus or minus 6 and B as plus or minus 2. Because it's a vertical hyperbola, I'm going to be following this list. See if you can identify all the features starting at your center all the way down to your slant asymptotes. Okay, take a second and pause the video to check your work. I got my center. Because it's a vertical hyperbola, I am adding and subtracting my A value to find my vertices to the Y. I'm also finding my focus the same way, adding and subtracting the C value to the Y to get the focus, because the center, vertices, and foci will all lie vertically on top of each other. I also have my slant asymptotes, Y plus 1 equals plus or minus 6 halves, or 3x minus 2. Okay, now we're going to take a second and see if you can graph your hyperbola. Pause the video and see if you can graph. Okay, check your graph. Make sure your center is at 2, -1. Your vertices are 6 units above and below your center. Your foci is 6.2 units above and below your center. And somehow I missed my lower focus. Okay, so I added that. To find my asymptotes, I am starting at my center and I'm following my slope. So I'm going up 6 and over 2 to find the first slope of my horizontal or my slant asymptote. And then my second slope, I went down 6 and to the right 2, or you can go up 6 and to the left 2 to make your slope negative. And there's your other slant asymptote. And then your hyperbola starts at the vertices and it's vertical, so it's going to curve up towards the focus and approach your slant asymptotes but never touch it. Start here, wrap around your focus, approaching those horizontal asymptotes but never touching it. Okay, this next problem says write an equation of an ellipse, and that should actually say hyperbola, with the given information. We want vertices at -7 and plus or minus 7, 0, and foci at plus or minus 8, 0. So the first thing that I'm going to do is I'm going to quickly sketch these points so that I can talk about my orientation of my hyperbola. Okay, once I plotted these points, I can see that these are lying horizontal. So this is going to be some kind of horizontal hyperbola. So I'm going to start with my basic equation for my horizontal hyperbola. Okay, now that I have this, the first thing that I want to talk about is the H and the K values. The H and the K can be found by finding the center. Well, I can find the middle between my two vertices or the middle between my two foci. And by finding the middle, I can see that the center of this ellipse is going to be at 0, 0. Again, you can find the average of your two vertices place or the average of your two foci using either one. The other important information that's being provided is now that I know where my center is, I can calculate the distance between the center and my vertex, and this is going to be my A value. And I can also calculate the distance between my center and my foci, and this is my C value. So I have an A value of 7 and a C value of 8. So you might be wondering, well, how does that help me find my B value? Remember our Pythagorean relationship for hyperbolas. We know that c squared is equal to a squared plus b squared. So if I have a and c, I can solve for b. Take a moment and see if you can find your b value. And I'm actually going to stop here at b squared equals 15 because that is part of the information. I really don't even actually need b. In order to be able to write my equation, I just need my b squared value. And so my b squared value is 15. I have my h and my k and my a value. And so now I can write my full equation. Because my center is at 0, 0, I'll have x minus 0. So I'll just put x squared. Again, x minus h squared. So x squared, because h is 0, over my a squared value. A is 7, so a squared is 49. I'm going to subtract, and I actually messed that up. I wrote down the equation for an ellipse, but the difference between an ellipse and a hyperbola is the subtraction between the terms. Okay, my y minus k, k value is 0, so I'll just have y squared in that numerator, divided by b squared. I know that b squared is 15, and this is equal to 1. So here's my equation of my hyperbola with the given features. Okay, try this last example on your own. Write an equation of a hyperbola with the given information. The center is at 7, 2. It has a horizontal orientation, and the slopes of the asymptotes are at plus and minus 2/3. Okay, pause the video and check your work. I knew that it was a horizontal orientation, so I started with the basic equation for a horizontal hyperbola. I knew that the center was 7, 2, so that was going to be my h and my k value. And then because they gave me the slopes of the asymptotes, I knew that for a horizontal orientation, that my slopes are plus and minus b over a. So my b value was 2, so that became 2 squared in my equation, and my a value was 3, so that became 9 when I did a squared in my equation. Okay, that's it for this video. We'll do more practice with this in class tomorrow.